Hello students, in this video lecture I will be discussing the next two questions from IIT-JAM 2020, and the first question is the sum of this series. We have to find the sum of this series. So let us solve this question. So if we observe that this series is nothing but summation n running from 2 to infinity 1 upon n into n square minus 1. You can substitute the value of n equals to 2, so you will be getting the first term, that is 2 into 2 square minus 1. Similarly, when you put n equals to 3, you will be getting this term and so on. So this series is nothing but 1 upon n into n square minus 1. So you can write this series as 1 upon n into n plus 1 into n minus 1. Further, you may break this now as n plus 1 minus n minus 1. So in the numerator you are getting a 2, so you can divide this summation by 2 also. So you are left with n plus 1 into n minus 1 into n, right? Now just separate these terms, so you'll be getting 1 by 2 summation n running from 2 to infinity. So when you will separate these terms, the first term will be getting n plus 1 over n plus 1 into n minus 1 into n. So n plus 1 and n plus 1 gets cancelled out. So you are left with 1 upon n into n minus 1. Similarly, on separating the next term, you will be getting 1 upon n into n plus 1. Fine. Now just open up these terms and you'll be seeing a telescoping series here. So this is 1 by 2. Put n equals to 2 in both these terms. So you'll be getting 1 upon 2 into 1 minus 1 upon 2 into 3. So this is the first term. Plus put n equals to 3. This will be 3 into 2 minus 1 upon 3 into 4 and so on. Fine. So you can observe now this terms gets cancelled out with this, and this similarly will get cancelled out with this, and the second last term will also get cancelled out. Now when you take n tends to infinity, so the last term will go to 0. So you are left with what? 1 upon 2 into 1 upon 2. So this is nothing but 1 by 4. So the sum of this series is nothing but 1 by 4. Moving on to the eighth question, if Sn equals to minus 1 per n divided by 2 raised to power n plus 3 and Tn equals to minus 1 per n divided by 4n minus 1, where n is running from 0, 1 and so on. So you have to comment that whether this Sn is absolutely convergent or it is conditionally convergent, or Tn is absolutely convergent or conditionally convergent. So let us solve this now. Now since our Sn is nothing but minus 1 per n divided by 2 raised to power n plus 3. So you can take the mod of Sn in order to check the absolute convergent of this series. So this will be 1 upon 2n plus 3. Fine. Now we know that 2 raised to power n is always less than 2 raised to power n plus 3. So just divide it, you will be getting 1 upon 2 raised to power n plus 3 is less than 1 upon 2 raised to power n. So what you did is you have find out that 1 upon 2 raised to power n plus 3 is always less than 1 upon 2 raised to power n. Now this is nothing but a GP series with the common ratio as 1 by 2. So this series will be convergent, right? And जैसा नेचर इस सीरीज का वैसा ही नेचर इस सीरीज का होगा by the comparison test. It implies that the modulus of Sn, this is a convergent. So it implies that our Sn is absolutely convergent. So first option is right. Now moving to Tn. Now Tn is given us to be minus 1 per n divided by 4n minus 1. So if we take the modulus of this, you will be getting 1 over 4n minus 1. Fine. Now you can apply any of the tests. If I consider this term as an, which is 1 upon 4n minus 1, and I consider bn as 1 by n, and I take limit n tends to infinity an divided by bn. So what do we get is 1 over 4n minus 1 into 1 by n. Fine. And when you take limit n tends to infinity, this comes out to be 1 by 4. So this comes out to be L. So by the limit comparison test, I can say if bn is divergent, so an will be divergent, because by p test. Okay? So it implies that an is divergent. So which is nothing but modulus of Tn is divergent. So this series is not absolutely convergent. So now let us check for conditionally convergent. So you can clearly observe that minus 1 per n divided by 4n minus 1 by Leibniz test. Fine. This series is convergent. So all the conditions are satisfied, and so this series is a convergent. So it is conditionally convergent. So the fourth option is correct. सो आई होप आपको ये दोनों क्वेश्चन समझ आ गए हो. फॉर मोर सच वीडियोस सब्सक्राइब टू माय यूट्यूब चैनल. थैंक यू.